Okay, hi everyone. Thank you for attending to this presentation on Slither. So briefly, who am I? My name is Josselin Feist. I'm a security researcher at 12bit. If you don't know my company, we're a security-oriented company. We work on blockchain projects since 2 or 3 years by now, and we are research and development focused. We build a lot of tools on the Ethereum ecosystem to help you to build a safer software, including Manticore, Echina, or Ethersplay. So the goal of this presentation is to discover what is Slither, how it works, what kind of application you can have on top of Slither, and how you can use it. So Slither is a static analysis framework for Solidity. It has 4 main use cases: the detection of vulnerability, the detection of optimization, the help to review and to understand code through visual representation, and finally, as a generic static analysis framework, it allows to build static analysis on top of its core. So it's open source, and you can install it through pipe. It has almost no dependency. So as a high-level overview, the way Slither works is that it takes the IST from the compiler. It recovers a lot of information from its IST. If we take the Solidity expression and convert this expression to its own intermediate representation, which is called Slither, we will go through this presentation on what is Slither and how does it work. From all this information, Slither will perform a set of inbuilt analysis to give rich information about the contract. From all this information, it's given to all the different usage of Slither, such as the vulnerability detection or the optimization detection. So the first use case of Slither is to detect vulnerability. Within the tool, there are something like 13 public vulnerability detectors. So Slither can detect really critical issues, such as the redundancy or the shadowing of variable, to more medium severity issue, to more informational one, such as an issue with a naming convention or big issue when you are using an old version of Solidity and so on. So if you run Slither on a code base, so in this example, you have a small piece of code. You have an issue because you use an address and you send Ether to this address, but you never assign this variable. So basically, if you call this contract, you will just send all the Ether of this contract to the address 0. If you run Slither on this contract, Slither will detect the variable which is not initialized. It will tell you at line 4 there is an issue because this variable is never initialized, and it will tell you when and where it's used. For each bug, you have also a reference, and if you go to the reference, you have a full description of the bug, what it is, why it's bad, and how you can prevent to have this kind of issue in your code base. This is true for each bug Slither can detect. So the list of all the public detectors are here. I say public detector because we have a set of private detectors that include more complex vulnerabilities, such as waste condition or overflow in your token manipulation. So we built Slither to be fast and precise. We use it in our internal audit, so we really need it to be like fast and accurate. It requires no configuration. You can directly run Slither on any code base. We have several ways to simplify its usage. We have an integration with Truffle, we have an integration with Remix, we are working on integration with Embark. We have several options to help you to triage the result. So as a developer, you can use Slither out of the box without configuration, without need anything, just run it on your directory and it will find the vulnerability for you. In addition to find vulnerability, Slither can also find optimizations that are missed by the compiler. Typically, if inside your code base you have one state variable that is never changed, it's always the same value, you can declare this variable as a constant. If you do so, the compiler will be able to do some optimization on this variable. Slither will help you to detect this kind of optimizations that are not directly done by the compiler. It's the same for functions that are public but never called internally in your contract. Slither will tell you that this function should be declared as external, so that the compiler will be able to do optimization on them. So the detection of vulnerability and the detection of optimization is the usage when you use Slither just by running on your code base without any option or anything else. If you want to perform some code review on a complex code base, sometimes it's a bit tricky to understand how the code base is architectured, how it works, what are the interactions between the contract and everything. Slither will help you because it provides a set of so-called printers, which are visual representation of your code base. For example, we have several graph-based representation, which will show you the inheritance graph of your contract, the call graph of your contract, the control flow graph of each function. We provide also a lot of summary of the contract. For each function, what are the variables that are read, written, and so on. What are the access for each function? Is it protected by his owner or not? And we also have this so-called human readable summary, for each contract will show you the code complexity, the restriction if you use a token, like for example, does the owner can meet unlimited amount of token or not. Here you have the full list of all the printers. To give you an example, here you have two contracts and a third one which inherit from the two contracts. If you print the inheritance graph, you will be able to see this code base as a graph-based representation. If you have multiple contracts with multiple inheritance, sometimes it's a bit complex to just follow everything to see, okay, what is overridden, where is like how the C3 linearization works and everything. Slither will help you to understand. So we build Slither as a generic framework. Because of that, we can use it as a library, and we are building utility on top of Slither. For example, we open source two utilities. The first one, check upgradability, which will use a Slither call to analyze your contract if it uses the delegate call proxy pattern for upgradability. You might be aware that if you use this specific pattern, there is a lot of issues that can occur on your code. For example, if you don't call properly all the initialization function, you might have trouble. So Slither will perform a set of heuristics on your code base to detect if this occurs. There is also this Slither find path utility. So sometimes when you have a complex code base, you have one internal function and you want to know how this function can be reached. It's sometimes a bit difficult to know. Slither will directly find all the possible paths that can reach this given function for you. So it will help you to kind of understand what are like all the possible paths for this function. And if you want to refactor your code or something like that, it will help you to kind of have like a good idea of how it's structured. It's written in Python, so you have a full API to take all the information for Slither and do any kind of analysis. The full Python API also includes data dependency. So data dependency is the ability to know if one variable can influence another variable. I will give more information about this in a few slides, but just to give you an example, in 5 lines of code, you can know what are all the functions that can change a given variable. So this can be like really useful if you are reviewing or auditing a code base and you want to understand how this function can be, how this variable can be changed. So, a few words about how Slither works. As I mentioned, Slither takes the AST from the compiler. So, if you take the full AST from the compiler, it's a bit complex to understand everything. The way Slither analyzes this AST is that it uses this refinement passing strategy where it will analyze the AST in different steps. Each step, it will find a new layer of information. The first layer will be the contract. It will find in this AST what are all the contracts, what are the inheritance, what are the state variable, and so on. Once this is done, it will analyze the function. What are the attributes of the function, what are the parameters, what are the control flow graph of the function, and so on. Then it will analyze the node of the control flow graph, and for each node, it will analyze the solidity expression. Once we have this solidity expression, we transform the solidity code to our intermediate representation. Once we have all this information, Slither performs a set of inbuilt analysis. Typically, it will find for each variable where it's read and where it's written, so that you have a really precise information about all the usage of all the state variables. It will perform a set of other heuristics. For example, it will detect if a function is protected, so if you need some kind of ownership to call this function. And finally, it will perform the data dependency for all the variables, so that you will be able to know if the value of one variable can influence another variable. So, as I mentioned, we have our own intermediate representation. If you're not familiar with compilation, intermediate representation are something really, really common. For high-level language like Solidity, C, Python, or whatever you are using, all these languages are meant to be usable and understandable by humans. They are not meant for be analyzed by machine. So people are usually building intermediate representation so that you have a representation of your contract which is more suitable for the machine. That's why we build this slit-layer representation. So our intermediate representation is pretty simple. We have less than 40 instructions. It's a linear intermediate representation. We have no jump. Everything is built on top of the CFG from Slitter. It's a flat intermediate representation in the sense that there is no nested operation. So you have one operator and a set of variables. And we perform a lot of code transformation and simplification just to simplify the analysis by the machine. Typically, we remove the ternary operator and we transform into the set of ifs and else. To give you a quick example, here how it looks with binary operation. We support index and mapping with member and index. We have a set of opcode for the new operator. Typically, if you follow the grammar from Solidity, when you create a new structure, it's a call to the structure. So we change this to a specific opcode, new structure. It's just to simplify the analysis from a machine point of view. Here you have a mapping of a mapping and you have a subtraction. It's transform this operation to 3 operations, as you can see here. So we build a lot of analysis on top of this intermediate representation. In particular, we have this form which is called a static single assignment, SSA, which is a really common representation in static analysis. Basically, it's just to have a form where each variable can be written at most once. This specific form is really, really useful and powerful if you want to build data dependency, so that like the data dependency will come for free and it will be really precise. Something which is a bit particular for our SSA form is that we do support state variable. So we do have a precise data dependency on the state variable. The analysis is also inter-procedural in the sense that we will track the change of the variable across function, and it's also inter-transactional representation because we can know if you have 2 functions, if one variable is changed in the first function and then another function depends on the change, we'll be able to track this fact by doing some kind of fixed point computation on our SSI. It will make a bit more sense with the example. Finally, we also have an alias analysis on storage reference. This is just to be able to analyze complex code base. Typically, if you have a storage reference in a function, it can point to many potential objects, so we track all the potential objects to be able to have a precise information about them. So if you have this contract, you have 2 variables, variable 1 and variable 2. You have 2 functions. If you only analyze the direct set function, you will see that variable 1 can be influenced by I, and if you only analyze the second function, you will see that variable 2 can be only influenced by variable 1, as you can see here. We do a fixed point computation to find that if you call both of the functions at the end, you will be able to know that variable 2 can also depend on variable 1. Being able to have this really precise representation and this precise information about the data dependency of your contract will help you to have precise vulnerability detector. And it's really like the main key to have precise analysis on top of Slitter. So if you are a developer or a code editor, you can use Slitter directly out of the box just to detect vulnerability and optimization on your code. It's fast, it's precise, there is no configuration, and there is a continuous integration support. So you can just, for each commit, you can just run Slitter and see what it found. If you want to go a bit deeper, if you want to have some understanding of a new code base, you can use the printer to improve your code understanding of the code. If you want to do a refactor of your code, it's also really useful. And finally, if you are a researcher and you want to perform and create new analysis, new static analysis on Solidity code, you can directly use Slitter as a library to build any kind of analysis on top of it. It's built to be as generic as possible. So for the roadmap, we are going to continue to open source new detector. We plan to improve the developer integration. For example, we are going to have a new Visual Studio plugin where you can just click on a variable. It will ask Slitter information about this variable. For example, what are the possible values of this variable? What is the dependency of this variable? And so on. We are working on an automatic patching through Slitter format. So for some issue that you can find in your code, Slitter will be able to directly provide you with a fix. We are working to integrate new language, in particular Viper. And finally, we're also working to improve our intermediate representation, to have a more formal representation of our IR. We already have work in progress utils that use symbolic computation, symbolic execution, and abstract interpretation. So here's a link to Slitter. I take also this opportunity, I think it's the first time we announce it in public, but we are going to release these cryptic services. So it's a web-based services where you can just upload your contract, have Slitter run all the public and private detector on this contract, and additionally, you will have support with Echidna and Manticore, which are a further and a symbolic execution framework, so that you can just upload your contract and you will have a lot of analyzer running on top of it to help you to build safer contract. If you want more information about this service, you can directly contact our CEO, Dan Guido. Finally, if you need help with any of our tools, you can directly contact us on Slack, on Ethereum, and every 2 weeks, we run a free 1-hour consultation on Hangout. So if you have any question, if you want to know more about our tool, if you have any problem, feel free to contact us. And we also give bounty for all our tools for meaningful contribution. Thank you for your attention. Do you have any question?
Thank you for your amazing talk and about the tool you are running. Also the ability to make your custom validations and custom detectors. So I have a question to the fact that mainly on the continuous integration level, almost everyone has, at any smart contract level development, we implement continuous integration to have a real check what is happening when we deploy smart contracts. Can you have, or do you have a comparison chart between other tools to really know what's inside yours with comparing the other ones? Because usually we used to add new checkers, and it's quite interesting to know which are covering what and which is the benefits of using one on the other one.
So you mean like a comparison kind of spreadsheet about all the possible tools?
MyTrill or similar tools around?
I can show you one if you're interested into. So at least for our tool, what we usually recommend, so in our GitHub, you will find 3 types of tools. You will find Slitter, which is a static analyzer. You will find Echidna, which is a fuzzer. And you will find Manticore, which is a symbolic execution engine. What we usually recommend is to run Slitter out of the box on any contract. Once you have some kind of confidence in your code and you have some prototype or you know kind of what the code is going to be, you can start using fuzzing for it. So Echidna, which is a fuzzer, will help you to find a bit more complex bugs that are missed by static analysis. Once you have some property test with Echidna, and you have some confidence about your code, you can start using symbolic execution with Manticore to ensure the property of some specific function in your code. So the way we do it usually is that we run Slitter. Once we have a good knowledge about the code base, we run the fuzzer, and once it's done, and if we want this additional step of security and safety, we run symbolic execution. Does that make sense? So like static analysis, we find the simple bug, like the things that it can find. If you want to find more complex bugs that are built on top of the logic of the contract, you will need fuzzing or symbolic execution. Does that make sense?
Hi, Josselin. Thanks for the nice talk and for all the efforts in building these useful tools for the people. So I'm actually more curious for the critic system. So what kind of formal verification do you support or aim to support in the future there?
So it's going to use Manticore for formal verification. And I don't have a lot of information I can share right now, but you can contact Dan Guido for more information. We're going to provide more information about this platform soon, but yeah. Thank you for your attention.